of control systems from here. And Sridhar, you can keep your mic turned on. Don't switch it off. I'll be keep on asking you, and you can also keep on asking if there is any doubt. Okay. So we'll start with this module one. So there are some very basic definitions. That is, what is meant by control systems? What are the different parts of control system? So you can see here, there is a first slide. So there are around 15 to 16 slides. I'll go through it fast. You have already seen it, but yes, the important small things I'll ask you to note down. So if you are having pen and paper, please note down this small things. So first thing is, what is the difference between open loop and closed loop control? That is a very important thing. And second thing is, what is the difference between feedback and feed forward control? What is meant by modeling? So modeling is nothing but whenever we are seeing a system, let us say a automobile or a vehicle is running on the road. So we want to just put every of its action into a mathematical equation. And the tool we are using for that is actually differential equation kind of a thing. That is dx dt, d2x dt, xt and yt, all those kind of things. So modeling is nothing but converting a physical phenomenon into mathematical equation. And there are mainly two types of model. One is impulse response based model, one is state variable model. And for this chapter, we will be doing transfer function based model. So transfer function based model is nothing but finding the ratio of output with respect to input. Now, what is control system? Control system is whenever we are having a process. Now, the process might be having some variables, like if you see a car or a vehicle, then the most important parameter for a car or vehicle is speed. And to control the speed, we are applying brake. And sometimes we are measuring how much is the oil consumption. Sometimes we are finding how much is the heat in the engine. So all these are parameters that can be controlled in the car. Sometimes car is running very fast, we want to take a turn. So in that case, we have to reduce the speed of the car, we have to apply brake. So this speed, acceleration, brake, temperature, and car gear, car clutch, how much to press, how much to go ahead, how much to stop. So all these things are actually the control variables inside the car. Now, what is the difference between open loop system and closed loop system? I give the example of a bucket which is being filled through a tap. So you just put a bucket, simple plastic bucket, below a tap, and you turn the tap on. What happens is the tap will be filling the water into the bucket, and even if the bucket is overflown, your purpose is solved, that bucket is filled. But even if the bucket is over filled up, the water will still pouring in, and the water will be wasted. So this is actually the open loop system, where there is no control, that if the process is complete, if the purpose is complete, then also the input variable will keep on coming. But this is not wanted. How can we solve it? We can solve it by closed loop system. Closed loop system, what we do is, at the top of the bucket, or at which height we want the water to be filled up to. So at that height, we put a water level sensor. As soon as the water gets filled up to that point, automatically the inlet water will be stopped. So all the open loop systems, by using a sensor, by using a feedback loop, we can convert into a closed loop system. What is the difference between open loop system and closed loop system? Firstly, open loop system is very simple. Closed loop system is a little complex. Open loop system does not have a feedback path. Closed loop system is having a feedback path. Like we teach in the class, if we don't ask student that how am I teaching, student don't tell me. So asking student is a feedback. How am I teaching? Am I teaching very difficult? Am I teaching fast, slow? Are you understanding it? So I'm actually sensing what is the student's understanding level. So whenever I'm saying a closed loop system, that should be having a sensor in the feedback path. So this is a very important thing, that closed loop system is having a sensor in the feedback path, wherever open loop system is not having a feedback path. So there's a very basic difference. Open loop system is simple, closed loop system is complex, little bit complex. Open loop system is not having any feedback, closed loop system is having a feedback path. There is a sensor in the feedback path of the closed loop system. As far as expenditure is concerned, open loop system is comparatively simpler, closed loop system is little costlier. These are the mainly difference. So for each of these differences, you should prepare at least 5 to 7 points. open loop system and closed loop systems. Okay, now we'll go for the next slide. This is an introduction to control system. What is a control system? Already have told you. I have given you the example of a car. That is, whenever a car is running, there are many parameters of speed, acceleration, temperature of the engine, and other things. So those are the parameters to be controlled. So the whole car becomes a control system. Examples of common control systems. So if you see that in our household there are a lot of control system. If it's very cold at that time, we are trying to heat up the room by using a room heating system. So room heating system and room cooling system also should be having some threshold. If it is heated up or cooled too much, then we are finding it uncomfortable. So we are setting a set point that yes, I want the room to be cooled, but cooled up to 22 degrees centigrade temperature. So you are setting that 22 degrees centigrade by means of the remote. So that thing is called a set point. Suppose if a boiler is to be heated up, boiler in a sugar factory, and we want temperature to be around 150 degrees centigrade. In that case, we set the temperature first, that I want the boiler to be heated up to 150 degrees centigrade. So in closed loop control system, whenever there is a feedback path, first we are supposed to set what is the target we want. That is a very important thing, and that is called as set point. So if you see closed loop control system or feedback system, at household there is a refrigerator, there is an air conditioner, there is a home heating system. It is there in home, which are the examples of common household closed loop systems. Industrial closed loop systems, air quality monitoring, you can say, quality control of any manufacturing process, that is how many units I am producing. uh, uh, by that I can check whether my productivity is online or productivity is less or more. Automobile assembly line, so all the automobiles are being fitted, their chassis, boards and other things are being fitted. How many I am doing, whether I am doing it proper or not, whether the assembly is proper or not, continuously that can be checked. So there is a computer based control system which is called a CNC, machine tool control, where every step there is a checkpoint. We can continuously check whether the machine tools are being fitted properly or not. Best example of control system or most sophisticated control systems are spacecraft and weapon control technology. So at every step of the spacecraft and weapon control technology, there is a feedback loop, because one process is finished, then only we can go for the other process. So these are some very critical and highly efficient system, and they're highly complex. Not only industry or not only household, but in medical field and in socio-economic field also there are lot of control systems, like in injecting insulin in the body of a diabetes patient. So depending on the present sugar level in patient's body, depending on his physical condition, automatically the amount of insulin will be calculated and injected to the person's body. Inventory control, inventory means how many things I want for the production of some output. So how much, suppose if you're talking about cooking, so at home what is the inventory? All the sugar, dal, rice, all this. So ingredients, whatever are the ingredients of a process are called as inventory. What are the outputs we are producing, that is also a part of inventory control. So inventory control, how much is required, how much you are using, how much will be required, all these things put together, we can say that there is an inventory control system. Growth of population in a country, financial market, stock market, all these things are examples of a control system, and they are all sort of a feedback control systems. Any doubts so far?
No, sir.
Yeah, I'll go forward. So next slide, what I'll show is the basic terminologies. I have already explained what is system. System is the interconnection of elements. What is a control system? Control system is interconnection of elements which can give us a desired response. So this is a very important thing. It is not only interconnection of processes, but we are supposed to get a desired response. Suppose I am saying a car. Okay, why a car? Because with that car, I want to reach a place which is 20 kilometers away from my home within 15 minutes. Okay, so every time there is a performance criteria, and whether the performance is satisfied or not, that we are supposed to check every time. So this is a control system, and this is what is meant by a system. What is a process? The process is a device or plant or system under control. Input and output relationship represents the cause and effect relationship of the process. So these are the very important thing for a process, that what kind of input you are giving, that is having some kind of function. And what is the process characteristic? So process is nothing but represented by another equation. So input is interacting with that process equation and giving us output. So we have done convolution in time domain. So output is nothing but the convolution of process function and the input. Okay. So process, whenever I'm saying process, three things we have to remember. One is xt, that is the input. One is ht, that is the process function. One is output, which is yt. So yt is equal to xt convolution ht. Now, this is a very basic structure of a control system. The block diagram below you can see there are mainly 5 to 6 things. First one is the command input. Command input, you can say what is expected from the controller. So controller actually is the thing which is controlling the process, and controller is having the onus, or controller is having the responsibility to produce the desired output. So controller is taking the command input, and then controller is generating manipulated variable, and controller is controlling the process. Now, when everything goes smooth, there is no problem. Process will produce the controlled output. But who causes the problem? The problem is caused by this disturbance input. So at every time there is a disturbance to the process, and this disturbance tries to deviate the controlled output from the desired output. So process without disturbance input, no problem. Process with the disturbance input, then the output is not desirable. So what is the job of controller is the controller counteracts the effects of disturbances to produce the desired output. So these are 4 5 very important things which we have to understand. First one is what is the command input. Second one is what is a controller doing. Controller is nullifying the effect of disturbances. What disturbances are doing? Disturbances are actually shifting the process output from the desired one to some undesired value. We don't want undesired defective output. Controller is trying to keep the output at a certain level. So main job of controller is to counteract the disturbance. And you can see that this process is not having any feedback loop. So there is no connection between this output towards the input. So this is a feed, this is an open loop system, and there is no feedback in this system. So this is an input output configuration of a very simple control system without feedback. Then again, the same thing is shown here for our body, but this is a without feedback path. So the brain is taking the control command input from is getting the command input from our wish. Suppose I want to drink a glass of water. So the desire comes in my mind. Brain takes the thing. It goes to the table. It takes a glass of water and it drinks. That's all. So job is complete. Okay. And always the brain will try to counteract the disturbance inputs. So that was a very simple thing, but now check this. This is an input output configuration of a closed loop control system. So the same process is there: command input, controller, manipulated, process, disturbance, and controlled output. But in this case, what we want is whether the output generated is perfectly in the tune of the desired output. So whatever is the output produced, that is again measured by, so here in the measurement on output there is a sensor part. So sensor is put in the feedback path. Again I am repeating, the sensor is put in the feedback path, and this feedback signal comes back to the controller. So command input minus feedback signal is called as error signal. So if error signal is too high, error signal is too high means the feedback signal is too much deviating from the command input. That means the output is actually too much deviating from the desired one. If output is very close to the desired output, then feedback signal will be very close to the command input. Then command input minus feedback, that is the error signal, will be less. So this we have to understand. What is error signal? Nothing but set point or command input minus feedback signal. If the feedback is almost same as the desired output, in that case error signal is less. So if error signal is less, controller understands that yes, process is going properly, so output we are achieving is almost same as the desired output. If error signal is too much high, that means controller understands that error is too much high means desired output is not obtained. Then controller will give some more hard control action, and the process will be controlled in a better way. Same example, suppose I am the controller and you are a student, you are the process. You are under a lot of disturbances, a lot of cricket matches here and there, a lot of mobile phones, so your result is not good. The controller wanted the result, you to get 80 marks, but what you are getting is 30. So what is the difference? So command input is 80 and output is 30, so difference is 50. So this 50 is the error signal because I wanted you to get 80, but you are getting only 30. So difference is 50. So 50 means I have to understand that yes, I have to give a very big control system. So what I'll do is I will sit with you every day. I will make the process disturbance free, and I'll see that you are getting 80 marks. So command input was 80. So I wanted you to get 80 marks in the subject, and you are getting 80 marks. So when these two are same, how much is the feedback signal? Feedback signal is also 80. Set point is also 80. So 80 minus 80, how much is the error signal? Error signal is 0. When error signal is 0, I can say system is error free. What is meant by system error free? System error free means whatever is the desired output, that is achieved. So whenever the desired output is achieved, controller will say that yes, my purpose is solved. So this is a very important thing. This is a closed loop process. This is a feedback process. And feedback process, one very big difficulty is feedback process first allows the disturbance to come at the output. So first I'll see, yes, some disturbance is coming and student performance is dropping. So first you get 30 marks. And then you give a feedback. Yes, sir, I have got 30 marks. I have got very less marks. Whereas I have set the bar as 80. So first, in case of feedback system, the disturbance comes and affect the process, deviates the output becomes very bad. Then this news comes back to the controller, and controller takes the action and bring it back to the normal value or the set point value. So this is a very big down point, or this is a very big negative for the feedback system. That is, once or for some time being the output becomes bad, and then after some 3-4 control loops, not in one shot the output is corrected, but in 3-4 control loops. So first this becomes 30, then you are taught, then in the next exam you get 50, then again I check if this is 50, this is 80, how much is the error signal? Error signal is 30. Then again I further teach you more, then likewise in 3-4 loops you will be able to achieve 80 marks. So feedback control, the main drawback is disturbance affects the output once or a few times, and then the process goes on, and then the process is brought back to the controlled desired output. This is feedback system, or with feedback loop, this is the control system. So here also you can check there is an open loop control at the top. This is the feedback control, and this is a feedback control with many variables. Okay, so this is called as multi-variable control system. You can say a car is like this, a multi-variable control system where many process variables are related. So these are some of the examples of control system. Let it be. Okay. Open loop control system. This is a room heater temperature. See, there is no feedback loop here. So this is a steam valve which is getting the heat from, and this is just given to the room radiator, and room is
Hello,
getting
sir.
heated. Yep.
So okay, sir. Here exam. Visible.
Okay. Yeah.
Okay.
Okay. So slide was not visible, right?
No, sir. Voice problem.
Watch. ठीक है. So now it is visible, right? Open loop house heating system.
Yes,
So
sir.
there's a without feedback system. There's an open loop system. We don't know how much is the temperature of the room. Okay, but room is getting heated up. So this is a very primitive, simple kind of a system. Now in the next slide, what you can see is what we have done is from the room radiator. So output of the room, we have put a thermostat. So this thermostat is put in the feedback path. So whatever is the room temperature, that information we get through the thermostat. So this thermostat is a temperature sensor, and it is kept in the feedback path, and we get to know how much is the temperature of the room. So previous system, only just by putting a sensor in the feedback path we are creating a closed loop system, because this big system becomes more smart. If the room temperature becomes very high or very low, we can come to know. So this is a closed loop system. Next slide, you can say, I think it is visible, it is a feedback control system block, and the same system, but we know what are the system blocks. So this is a very important thing. I think you should remember this slide number 15, and this block diagram is frequently asked in the exam. So what are the things? First one is a reference input. Previously we were calling it command input. Now we are calling it reference input, or this is called as a set point. So many name is there. This is the summing junction. Summing junction is taking two inputs, one from reference input and another from the feedback. So this plus and minus, so reference input minus feedback signal is the error signal or actuating signal. You can see here. So this is the actuating signal or error signal. This is nothing but reference input minus feedback. So if the error signal is more, control logic will be very high. If the error signal is less, control logic will be less. Error signal is more means the output is too much deviated. In that case, higher amount of control signal is to be generated. Okay, so error signal is given to the control logic or controller, and then controller as per the error signal is producing the control signal, and that control signal is given to the plant. So plant is control having two things. One is the actuator. So actuator is something, it's like a relay. Actuator is taking the control signal from the controller and giving it, passing it to the actual system or plant to be controlled. Okay, so actuator can be solenoid, actuator can be valves, actuator can be relays. Okay, all those things are there. So actuator is actually a connect between the controller process. Okay. And then there is a process, and always the processes are under disturbance. And the controller wants to nullify the effect of this disturbance, and finally the controller is producing the final output. And whatever is the output of the controller, that is again feedback. So here is a sensor put in the feedback element, and then it is again giving back to the controller. So this is a negative feedback kind of a thing. That's why this minus sign is there. And if it's a positive feedback, then this sign will be plus. Okay, is like that. So this is the feedback system. And what are the problems of feedback system is given there. So I'll be sharing these notes with you. You can find out. So there's a very example and working of feedback control system which is given there like this. This is a servo mechanism. There is a feedback in the servo mechanism. There's a servo mechanism based antenna and solar panel position control. So as the sun is moving continuously, this solar panel also will be moving continuously. So very slow shift of the sun position on the sky, the solar panel angle is going to be rotated. Okay. So this is a feedback system example. Uh, Feed forward system. This is a feed forward system. I can show you. This is a feed forward system. What is a feed forward system? The best example is water heater. But when as soon as you enter the bathroom to take a bath in a very cold day, you don't want the water to fall on your body. Water is falling on your body means you are sensing that yes, water is very cold, and then you are starting the heater. That is a feedback system. Okay, but in cold time we know that water will be very cold, and we don't wait for the water to fall on our body and give us a chill. So what we do is as soon as we enter the bathroom, we start the heater. Okay, and water gets heated up and then it falls on our body. So this is called feed forward control system. We do not want the disturbance to defect us and then we start the control system. No, as soon as the process starts, the control action starts there. So you can check here. This is that cold fluid input, and here is the steam input. So steam is actually heating up this cold fluid, and this cold fluid is getting heated up and coming here, and directly this is hot processed fluid, and this is coming and falling on our body. So as soon as we enter the bathroom, we start the heater, and this water is getting heated up, and here we are finding directly heated water, and this water we are enjoying on our body. And see that there is no feedback path, because we already know that water will be cold. We already know that this is a cold time, water will be cold. So before entering the bathroom only, before taking the shower only, I am starting the heater process. So what is feed forward control? Feed forward control means you know what is going to happen in future, and depending on that you are taking a correction from beforehand. You are not allowing a student to fail and then come back to you and then you are teaching him and he is passing. No, if I am seeing that some student is weak in some subject, before the semester only I give him tuitions, before the exam only I teach him quite a lot, so that he clears the exam with good marks in the exam. Okay, so that is nullifying the disturbances before the disturbance affects the output in a negative sense. So feed forward control is also is having a foresight. Okay, it is a D type of controller, a differential type of controller. It actually understands that if the situation goes like this, process will be disturbed and the output will be very bad. So do not let that happen. Beforehand only take a action. So feed forward control is a very smart kind of control that is there. So what we have explained till now, we have explained till now what is open loop control, what is closed loop control, what is feed forward control, and what is feedback control. Shridhar, visible?
Yes, sir. Visible, sir.
Yeah. Last thing, what I'll tell you, I know time is running out. Last thing, what I'll tell you is what is the difference between. Uh, uh, so here is a PPT I am trying to share. Can you see a block diagram, configuration of the basic digital control scheme or something
No, sir.
visible?
Not visible, sir.
Okay, I'll just see. Yeah, I'll just tell you. I'll show you the digital control system block diagram, because whatever I have shown so far, this is nothing but a analog control system. What I'll show you, the DCS or digital control system block diagram. Is it visible now?
Yes, sir. Visible, sir.
Yeah. So this is actually configuration of the basic digital control system. Can you find what is the difference? Can you just see the previous feedback system block diagram I have shown and this block diagram I have shown? What are the differences? Can you just point out to one or two things?
Sir, digital analog to digital converter is there, sir?
Yes, so that is the main thing. That is the main block. So can you see this pointer I am circling? Can you see this pointer I am circling? That is analog to digital converter, computer, and digital to analog converter, and clock. What does a clock do? Clock actually maintains the time for the whole system. Okay, so clock is actually there for synchronization of the whole system. So this is actually the block diagram of a digital control system. So if you have pen and paper, you can write down that this block diagram is very important, and this is one thing you must have to prepare. And because this is very good for understanding, and there is a whole subject which is called as digital control system. So first thing, what is the difference between analog control system and digital control system? The main importance is this A to D computer and D to A block, because whatever signal is coming from the output, so this is the feedback path. And now in the previous feedback system, there was only a sensor, and in this feedback system there is anti-aliasing filter, there is sample and hold circuit, and then there is the sensor. So instead of one block, there has become three blocks in feedback path. That is the first difference. Second difference is in the forward path, before control, so the final control element is the process. Final control element means actuator. This is the plant is again under disturbance, and here is the controller, and controller is not only a controller is a computer, and that thing is having an analog to digital, digital to analog, and clock part. Why there is an analog to digital converter? Because whatever signal coming from the output, this output signal is analog type, so controlled output is analog type, and computer is a digital device. So this output, if you want to feed to the computer, first it has to be digitized. That's why this analog to digital converter is there, and there is a set point. Okay, and what is the error signal now? Error signal is nothing but the difference between this digital set point and this A to D converter output. So difference between these 2 points, that is digital set point and A to D output, is nothing but the error signal. So this error signal is calculated inside the computer. Now this computer is nothing but that digital controller, and this controlled signal is produced at the output of the computer, and it has to be given to the plant, whereas the plant is analog. Okay, the final control element is analog, but computer is producing a digital control for that. So digital control cannot be given directly to a final control element, so that's why this D2A converter is there. So this D2A converter converts this computer output to a equivalent analog signal, and that will be given to the final control element. Rest everything is same. So this computer is trying to nullify the effect of disturbance on plant. It is there. After output of the plant is actually the feedback. It is sensor, anti-aliasing filter, and another thing, and then it is digital set point. Okay, so the main difference between analog and digital control system is this initial block, that is A to D converter, computer, and D to A converter, and all these three things has to be in synchronization. That's why a clock is there, which is connected to A to D, D to A, and computer, everything. And finally, there is another difference, that is a feedback path is not only having a sensor, but it is having anti-aliasing filter and sample and hold circuit. Okay, so for time being, these are the things that you have to prepare. So mainly what we have done today is we have done a very basic control system configuration. What is meant by feedback, what is meant by error signal, what is meant by summing junction, what is meant by input, command input, disturbance, controller, actuator, and all those things. So that is the first thing. Second thing is we did three differences. So these three differences are open loop versus closed loop, feed forward versus feedback, and analog control system versus digital control system. So whatever feed forward feedback we had shown, those were all analog control system. Open loop and closed loop I had shown, that was also analog control system. And finally I have shown you a digital control system. So this completes the first part of this first chapter. Okay, so next day we will start with, that is tomorrow, we will start with the second part of this fourth chapter, that is the transfer function based modeling. Okay, Sridhar,